Hello and welcome to Global with me, Tim Wilcox. Scientists are saying that it is a discovery so significant that it will usher in a new era for our understanding of the universe. Researchers at LIGO observatories in the United States say they have successfully detected gravitational waves. Albert Einstein predicted their existence a century ago, but they have never been detected until now. Well, here is the announcement made in Washington just a short time ago.
Ladies and gentlemen, we have detected gravitational waves. We did it.
Well, researchers at LIGO observatories say they have detected those amazing simulations as well, and they emanated from the collision of two black holes, 1.5 billion years ago. What does it mean? Our science correspondent Palab Ghosh has this report.
Gravitational waves are created whenever there's a seismic event in the universe, such as an exploding star. These waves ripple across the galaxy at the speed of light, stretching and squeezing space as they go. But they're incredibly hard to detect because when they hit the Earth, they give it the tiniest of jolts that's barely the width of an atom. By scanning the skies, these waves will enable us to see things that have been completely invisible to the telescopes we have now. These can only detect light. A gravitational telescope will be able to form images of the 99% of the cosmos that astronomers call the dark universe, black holes, and strange objects known as neutron stars, which were once giant suns that have collapsed to just a few kilometres. And they'll be able to see much further into the universe and further back in time, right up to the moment of the Big Bang.
Well, with me now is one of the key contributors to the international study in the US, Professor Mark Hannam from Cardiff University, from their School of Physics and Astronomy. Well, congratulations. What was your part in this discovery?
So the part that I played and people that I work with is that we produced the theoretical calculations which made it possible to decode these signals that we saw and work out what they were. So
you took Einstein's theory.
Yes.
And then how do you apply those calculations to what LIGO is actually doing in terms of trying to detect them?
So we solve Einstein's equations for two black holes colliding. There's lots of possible sources of the gravitational waves. My favorite was always binary black holes, and fortunately that's what we saw. And so
binary black holes as in two black holes colliding, rather than, could you have three black holes colliding?
Well, we saw three black holes. There were two in the beginning and there was one at the end. So yeah, you could have three, but two is much more likely. So that's what we've been spending years and years doing, all these calculations in preparation for a moment such as this, where we can use these calculations to work out what exactly it was we saw.
So it underlines yet again what a genius Einstein was. How often do we think that there are these collisions?
Yeah. So yeah, that Einstein was a genius was not one of the discoveries today. We knew that already. How often? Yeah. So this has always been the question: is how often does this happen in the universe, and how often it happens, of course, determines how many of these we see. And we thought there was a possibility it would take years and years to see them because maybe there weren't very many. And the fact that we've seen one essentially before we started looking, it was really in the days, even just before we turned on the detectors, or that we started looking closely at the data, that we saw this. This suggests that there are a lot of these out there.
But so is it all around us? I mean, where are these detectors being pointed at, or is it just basically it's everywhere?
So there's a lot of difficulties in detecting gravitational waves, but one advantage that we have is that we can see things from any direction. We don't care what the direction is. So yeah, these came from roughly somewhere in the southern hemisphere, is what we know.
But you could pick them up in the northern hemisphere?
Yeah, sure. We can pick them up from pretty much any direction.
Okay, and so another...
To put it, the way that these things are really is, and you can listen to the signal, you can go online and hear what this thing was, and they really are at audio frequency, so it's a sound. And these detectors are like microphones. And just like a microphone, you don't care where the sound's coming from, you can hear it from any direction.
Okay.
So we are listening to the universe.
Okay, that's an interesting way of putting it. So our science correspondent said it was the discovery of the century, and I think by that she meant actually the 20th century or the 21st. I mean, is it that significant?
I think it is, and I think what makes it what really makes
should we think it is, or should I think it is?
You should, and the reason is because this is just the beginning. Having these detectors that we've just turned on, we are already planning. We have plans in place to make them more and more sensitive. So we're going to see more and more things, and this is the beginning of a whole new kind of astronomy. And what's important about that, it's not just finding stuff in the universe, is that every time we've turned on some new kind of instrument, Galileo looking at the heavens with a telescope, or radio telescopes last century looking at the Big Bang, every time we've done something like this, it's completely upended the way that we see the universe. And so what's very likely is that at some point here there's going to be a big surprise, and it's just going to completely change everything.
Ah, fascinating. And but it doesn't change the theory of the Big Bang and everything else like that, does it? I mean, it's confirming what you and other astronomers have been saying for decades now.
Right. Everything is completely consistent with Einstein's theory.
Yeah.
The only thing that we didn't know was how many of these things are out there, or even if there were binary black holes. We didn't expect binary black holes would be the first thing we'd see. We thought it would be something else.
Right.
So it was a complete surprise it was binary black holes. It was a complete surprise that the signal was so loud. I think Dave made this clear in his announcement, that this signal was, there was no doubt that we saw it. There was no quibbling. It was really loud. It was unambiguous. There was no doubt.
All right. Okay. Yeah. It is absolutely fascinating. Thank you very much indeed for coming in, Professor. Right. Now let's turn our attention